when we come across, when we touch a knob, a metal knob of a door, or when we touch a cloth, a silk cloth or woolen cloth, especially in a dry weather, and we may hear a spark or a mild shock is produced. And what does make this spark, or what does make this mild shock? It is a discharge of electric charges. Then what do you mean by an electric charge? Electric charge is an intrinsic characteristics of fundamental particle constituting the objects. So it is a characteristics that is automatically accompanies such particles. It may also be defined as it is something possessed by materials, objects, which makes possible for them to exert an electrical force or to respond to an electrical force. Then what is the source of these electric charges, or how does these electric charges produced? The charges are produced especially when the two objects are rubbing each other, or we may supply energy to the objects. And when we supply the energy to those objects, what happens? They remove the electrons that resides on the surface of the objects. And how does electrons remove? Or the object that holds the electrons loosely will remove by the other one, or they lose the electrons. The object that held the electrons tightly may gain electrons. So by losing the electrons or by gaining the electrons, electric charges can be produced. And these electric charges produced by losing or gaining electrons. When an object loses electrons, it gains positive charges. And when an object gains electrons, then it gains negative charges. Source of the electric charges are of two kinds, positive charges and negative charges. As we already discussed, how does the positive charge and the negative charge produce? And we supply the energy, and this energy makes the replacing the electrons that resides the surface, or electrons that reside the surface of the object. Charges are acquired after rubbing each other, or when the charged bodies are brought in contact, and it is possible only if the charges are acquired or developed on the two bodies being rubbed. We already know that these charges are transferred from one object to another, but when the two or more bodies are brought in contact. So that we call it charge by conduction. So when two objects are brought in contact, and the positive or negative charges that resides in, they can be transferred from one object to another, and that is we call it charge by conduction. So on the basis of this, their ability to conduct the charges, and they are classified into two materials. They are conductors and insulators. Conductors, as we already from the name only know, and from the name itself we can understand, the materials that can allow the electricity or charges pass through them easily are called conductors. And while insulators, they offer a great resistance against the flow of charges. They do not allow the electric charges to pass through them easily. So they are insulators and conductors. Two kinds of materials are available. Now, another way of acquiring charge, that is charging by induction. So, in charging by conduction, the objects are brought in contact, but in charge by induction, the objects are not really brought in contact, but still it can gain or lose electrons, or can form the charges. And let us see how it is possible. Here let us see an example. And two metal spheres, let's say the name A and B. and these two metal spheres, they are kept in a stand. Okay. So allow these two metal spheres A and B. They brought nearby, and we may say that they may brought in contact. So these two spheres, they have charges in it. And now bring a metal rod or a positively charged metal rods brought nearby these two metal spheres, and taking care of that this metal rod does not come in contact with the metal spheres. So suppose this rod is fully positively charged. So as we know that from the nature of these charges, these two charges have its own or their own properties. So like charges, they repel each other, and like charges, they attract each other. When a positively charged rod is brought in contact with a metal sphere A, but it does not touch it or does not brought in contact with the sphere. So since the metal rod is completely positively charged, then the electrons that reside loosely on the surface of these metal spheres will get attract towards the positively charged rods. So what will happen? These electrons will start to accumulate on the side where this metal rod is brought in. And what will happen to the other sphere, metal B? And since all these electrons are accumulated here, since electrons have the negative charge, then it will be attract towards the positive charge. And what will happen to the rear side of this metal sphere? And all the positive charge will start to accumulate here on the rear side of the sphere. Not all the charges, most of the charges or loosely held electrons will attract towards or move to the surface of the metal sphere A, and the positively charged particles will accumulate. Most of the positively charged particles or charges will accumulate on the rear side of the metal sphere. Now, see, since these charges are accumulated here, so what will happen? All the light charges are accumulated here on one side of the sphere. So all the light charges, they will start to repel. Okay, all the charges will start to repel each other, and then the same will happen here also. So even though there is a force of attraction between this metal rod and the metal sphere, but the charges that accumulate on the surface of this metal sphere repel themselves. So two kind of forces are acting on the metal sphere and the metal rod. A repulsive force, the same time, and an attractive force. And then what happens? So the metal sphere A is completely or most of they are negatively charged, and positive charges are accumulated in metal sphere B. And now this metal sphere A and metal sphere, they separate from a distance and keep the metal rod nearby. So what happens? And as this metal sphere, now they will contact each other, and now they are separate each other a little distance. So what will happen? These charges, the metal rod, they will be separated, and still the metal rod is nearby the metal sphere A. So the negative charges will remain here or resides on the surface of the sphere, and the force of attraction exists. At the same time, the force of repulsion exists, and but these two metal sphere will be opposite, or they are majority of the charges in sphere A will be negative, majority of the charges in B will be positively charged, and now they separate. So then the positive negative charges in the metal A, they will rearrange themselves, or it was accumulated in the one side of the metal sphere, and as it fall apart, what happens? These negative charges rearrange themselves. Okay, so like this, the metal sphere, because it was accumulated in the one side of the metal sphere, now it is rearrange themselves on the metal sphere. And what will happen to the metal sphere B? And metal sphere B, these positive charges, they rearrange themselves in the metal sphere. And now the third case, remove this metal rod which is positively charged. So now what will happen? As the metal rod is removed, positively charged metal rod is removed, then what will happen? The whole sphere will redistribute their charges equally among the sphere, and the B also, then these charges will be redistributed equally among the sphere. So that means now this sphere is negatively charged sphere, and this is positively charged sphere. And this is how we charge a metal object, or charge a material or object by induction. That means without touching each other, or without bringing contact with each other. Electric charges, they have their own properties. So the basic properties of electric charges are, they have additivity of electric charges. Suppose a system of charge consists of n number of electrons. Okay, n number of electrons in it. For example, charge Q1, Q2, Q3, etc., and Qn. And the total charge of this system will be, or can be calculated by simply adding them together. That means the total charge of the system, the charge can be taken as Q. Q is equal to Q1 plus Q2 plus Q3 plus etc. plus Qn. That will be the total charge of that system. That means then simply we algebraically added the whole charges, or magnitude of the whole charges together, or constitute the total charge of the system. And next is charge is conserved. That is the second property, basic property of charge. Charge is conserved. The net charge carried by any isolated system neither be created nor be destroyed. So the total charge in a system is always conserved. That is the second property of basic property of charge. And third is quantization of charge. And it has been experimentally proved that all free charges are the integer multiples of a basic unit of charge. Okay, all the electric charges are the integer multiples of a basic unit of charge, that is, which is denoted as E. So, and thus, if a charge Q on any system of object, or any system or of an object, then this charge can be defined as Q is equal to, then that will be the number of charges and the basic unit E, and where n is an integer and E is the basic unit of the charge, and this is called the quantization of charge. These are the three basic properties of charges. One is additivity of charges, and charge is conserved, and third is the quantization of charge. The value of an electric charge is experimentally found that 1.6029192 into 10 raised to minus 19 coulomb. Okay, 1.6012 into 10 raised to minus 19 coulomb is the value of a charge.